Alright, this is the lesson for day 152. We're going to talk about binomial probability. So binomial, we see the prefix bi meaning two. It means like there could be two outcomes for anything to happen. So for example, like when I flip a coin, that's binomial probability. How many sides are there to the coin? Two, right? There's only one heads and one tails. And binomial probability is, are you successful at what you wanted to do, or are you not successful at what you wanted to do? So let's say I wanted a heads, right? What's the probability of me being successful at getting a heads on this? 1 out of 2 or 50%, right? And I wasn't successful. Okay, does that make sense? Another thing that we could look at are when we take tests, right? Let's say you start guessing. That's binomial probability. You could either get the answer right or you get the answer wrong. Okay. So if you have 5 bubbles on a multiple choice exam or test, okay, and you guess, what's the chance or probability of you getting one of them right? 1 in 5, or how many? Excellent, 20%, that's right. What's the chances of you getting it wrong? 80, right? And what did you notice about 20 and 80? What did they add up to? 100, right? 100% of your opportunities or outcomes are everything that can happen, failures or successes. Or just like yesterday, when I was hey, if I get 3 heads in a row, I get $5. What was the chance of me getting that $5? What was the percentage we figured out from yesterday? Good. I had a 12.5% chance of success, right? What was my chance of failure, though? Or what was my probability of failure yesterday? 87.5, okay? So notice how those two numbers add up to 100, right? So those are two concepts. Okay, and today I'm going to answer a question on people who guess on tests, okay? Let's say you have 4 problems you need to guess on the test. Is that good or bad? Raise your hand if you've had 4 problems in a test you've ever had to guess on. Okay, I'm going to show you today how much of a chance you will get at failing the test because you're guessing, okay? So today I'm going to prove to you mathematically why that happens. You'll understand why, okay? So, think and recall, okay? So, we're going to connect something we've done before. So, let's just say that there was you at a test, okay? And you are just guessing at one... This is you, by the way. Imagine yourself there. You're guessing at one true-false item, on a true-false item, okay? And... there you go. You could either get it right or wrong, right? Would you agree with that? So you have a 50% chance of getting it right, and you have a 50% chance of getting it wrong, okay? So what I want to do is ask you, how many ways can you get it right? How many ways can you get the answer right with this first chance? 1 way. You could get the answer right in 1 way, right? How many ways can you get it wrong in this first way? 1 way also, okay? Does that make sense so far? Now let's say you're like, I have to guess on 2 problems, okay? So let's say you guessed on the first one, let's say you did get it right, but on the second attempt, you could either get it right or you could get it wrong, okay? Does that make sense? Or let's say on the first attempt you got it wrong, right? And you were going to guess, and you could either get it... I'm sorry, the first attempt, you could have gotten it wrong. And you could have either guessed to get it right, or you could get it wrong, okay? So now we have a few outcomes here, right? You could have either gotten it... And I'll highlight it here so you can see it on the video. You could have either gotten the first question right and the second question right. Does that make sense so far? Or you could have gotten the first question right and the second question wrong, right? Or you could have had the first question wrong and the second question right. Or you could have the second question wrong and first question wrong and the second question wrong. Does that make sense so far? Okay, I got a question for you. How many ways can you get both questions correct? How many ways? Both questions correctly. Only one. First question correct and second question correct. Do you see that? Are there any other ways you could have gotten both questions correctly? No. So how many ways? 1. Okay, good. All right? Actually, let me delete these. Only one, okay? How many ways could you have gotten one of the questions right and one of the questions wrong? 2, right? You could have gotten this one right and this one wrong, right? So that's one way. You could have also gotten this one wrong and this one right. Does that make sense? So how many ways could you have gotten at least one problem right and one problem wrong? 2, right? Okay. How many ways could you gotten both problems wrong? Only one way. Okay. So what are you noticing about what I'm making here on the right-hand side? Pascal's triangle. Does that make sense? So let's just say you guess on the third problem now, okay? How many ways could you have gotten all of the questions right? 1. How many ways could you have gotten at least 2 of the questions right? 3, right? How many ways could you have gotten at least one question right? 3. How many ways could you have gotten all the questions wrong? 1. You see? You see the pattern happening here? So we're going to use Pascal's today, okay? And we're going to talk about all the chances possible. So when you guess on a test, you see how many possible chances are occurring now? Just by guessing on 2 questions on a test, you could have had 4 outcomes happening, right? Okay, we're going to talk about the percentages here. And if you think about it mathematically, it'll help you to make better decisions, okay? So here are the steps, okay? Your goal is to expand p plus q to the nth power. So we're going to be working with this, and we're going to use Pascal's here. And when we talk about p represents the probability of success, right? When I was flipping the coin, I was like, what's the probability of me flipping it correct 3 times, or successfully 3 times? 12.5%, right? And then q represents the probability of failure. So that means if my probability of success is 12.5%, my probability of failure is 87.5. And then n represents the number of trials. So when I flip the coin, how many times was I going to flip it? 3 times, right? Okay, so we're going to identify these things, use Pascal's, and then we're going to identify the probability of each outcome, okay? So this will take a little bit of math work, but then I'm going to show you the concept too as I go, okay? So number 1, each problem will take a little bit longer, so I'll only show you a couple problems here today, okay? Here we go. So on number 1, I'm going to hide number 2 for the sake of time. Okay, number 1, okay? The question is, what is the full probability distribution of each scenario? Meaning, like, what are all your possible probabilities? So here's the scenario. Okay, all these are application problems, so you need to imagine what's going on. Suppose you guess on 4 questions of a 5-choice multiple choice test. What are all of your probabilities? Okay, so we're going to guess on 4 questions. Okay, when you guess on questions, do you feel pretty good about yourself? No. Do you think you could get at least 1 right? 2 right? 3 right? At least? Okay. So I'm going to talk to you about the mathematical reality of what happens when you start guessing, okay? So the first thing I need to do is figure out my P, Q, and N, okay? So P, remember, is the probability of me getting a success, okay? So, what's the probability? If I guess on 1 problem out of a 5-bubble or 5-choice tests, what's the probability of me getting the answer right? What's that? 20%. How do I write that as a decimal? Good. So the probability of success for that 1 problem is going to be 0.2. Okay? What's the probability of failing on that 1 problem? 80%. It's pretty high, right? Super high. Okay? How many attempts am I going to take in this scenario? How many problems am I guessing at? 4 problems, okay? Here we go. So now we're going to start with Pascal's. Eyes up here, eyes up here. So I'm going to go to the 4th level of Pascal's. So let's see if you remember. First number is always 1. What's the second number on the 4th row? 4. The next number? 6. Next number? 4. And then? Good, okay? 1, 4, 6, 4, 1, okay? And then I'm going to set up my problem based upon P plus Q to the nth power. In this case is going to be 4. Okay, so I'm going to have P to the 4th, P to the 3rd, p squared, p to the first, p to the 0. Okay, and then I'm going to go back to q. It's going to be q to the 0, q to the first, q to the second, q to the third, and q to the fourth. Okay?
Question.
Yes.
Why did you do 1, 4, 6, 4, 1?
Because we're going to go to the fourth level of Pascal's. We're trying 4 attempts. We have 4 problems we're guessing at. So we have to use the fourth level of Pascal's. Remember, the fourth level starts with the second number. 1, 4. 6, 4, 1. Remember Pascal's triangle? Remember this from earlier this year?
Yes, I remember that, but why? How did we get that? I don't remember how we got that.
If you look at the story, I'm making 3 trials. There are 4 trials on my test. I'm trying to guess correctly 4 times on the test. So that's why we're using the fourth level of Pascal's.
Okay, so how did you get the 6 then?
From Pascal's triangle, watch, I'm making it over there on the right. Remember Pascal's, you add up the 2 numbers above it to get the next one, right? 1, 3, 4, 3, 3. That's okay, that's what we're reviewing. Remember that?
Yeah.
This is nothing new. It's okay if you forgot. Do you remember this? Give me a thumbs up if you remember this. Okay, good. Okay. So, now, P, what did P represent again? What was the number we said?
Probability of success.
Probability of success. In this case, what's the probability of me succeeding on guessing? 0.2. Okay, so now I'm going to replace P's and Q's with the various probabilities. So we got 1 times P, which is going to be 0.2 to the 4th power. Okay, and then we got Q, which is 0.8 to the 0 power. Okay? Does that make sense so far? And we're going to do the next one. 4. P, 0.2 to the 3rd. Then we got 0.8 to the 1st. And then we got 6. 0.2 to the 2nd. And then we got 0.8 to the 2nd. And then we got 4, which is 0.2 to the 1st. And 0.8 to the 3rd, and then we got 6. I'm sorry, 1. Sorry, it looks a little crooked there on that one. 6. Oh, no, not 6. 1. 0.2 to the 0, and then 0.6. Or I'm sorry, 0.8. I keep wanting to say 6. 0.8 to the 4. Okay. All right. Remember doing this? Okay, so this could be kind of hard to do in our heads, so we're going to get our calculators out. So I would like you to participate if you're on the video practicing, okay? So getting your calculators out, please. Okay? So right now we're just doing the procedural stuff in math, and I'll explain how this fits, okay? So now we're going to clear it out. So we're going to do 0.2 to the 4th. And we're going to multiply that by, this is times 1, and this, what's anything to the 0 power? 1. So right here we get a decimal of 0.0016, and that's our probability here. So how do you write a decimal as a percent? Move the decimal 2 over, so it's going to be 0.16%, okay? And I'll explain what that means. Next one, let's do this one, the second one. Okay, here we go. So clearing your calculator, 0.2 times 0.2 times 0.2 times 0.8 because it's to the 1st, and then times 4, and then we get 0.0256, and move 2 decimal places to the right, which is 2.56%. Okay? Next one, we got 0.2 times 0.2 times 0.8 times 0.8 times 6, and we get 0.1536. Okay? And we can write that as a decimal as 15.36%. And then the next one, we're going to clear out a calculator. 0.8 times 0.8. I'm sorry. Start with 4. 4 times 0.2 times 0.8 times 0.8 times 0.8. And we get 0.4096. And this could be 40.96%. Okay, and then the last one we're going to do 0.8 to the 4th power times 1, which is itself is 0.4096 again, and that's 40.96%. Okay. Okay, so what does this all mean? Okay, ready? So we got a first term, second term, third term, fourth term, and fifth term, okay? This first one, I'm going to change the colors here. This means you get all 4 problems correct. Okay? The percentage of you getting all 4 problems correct is 0.16%, okay? The percentage probability of you getting 3 problems correct, 3 problems correct will be 2.56%. The probability of you getting 2 correct, 2 of them correct, will be 15.36%. The probability of you getting 1 correct, only 1 correct, will be 40.96%. And then the probability of you getting nothing correct, 0 correct, is 40.96% also. Okay? So this is what happens when you guess on 4 problems, okay? That's on a 5-choice, multiple choice test. Okay? So do you have a high probability of getting the answer right or wrong? Right? Does that make sense? Okay? So what's the probability of you getting all the problems wrong? What's the percent probability, everyone? Is that good or bad? That's not good, right? That's a pretty high probability. Now, what if you get 1 right? What's the probability of you getting 1 right? Good. That's pretty good. At least you might get 1, right? Okay. Now, what's the probability of you getting 1 or none correct? Let's add these together. Let's help get your calculators. What's 40.96 plus 40.96? Add these two together. What's the probability of both? Good. So the probability of you getting 1 or none is 80.92. Is that good? That's pretty bad. Okay. What if you were to get 2 correct? 2 correct is 15. Let's add 15 plus 40, or sorry, 15.36 plus 40.96 plus 40.96. What's the probability of you getting 2 or less correct? Dang. Would you be happy to get 2 correct? Really? What's 2 out of 4 problems? What grade is 2 out of 4? So what is the probability of you getting an F by guessing on 4 problems? Well, how many percent was that again? Oh, 97 point, right? That's pretty bad, right? So should we be guessing on tests? Does that make sense how this applies? Okay, cool. So this is how you do the problem. This is not a new concept in our procedure. We've done Pascal's before, but we're applying it to find probabilities. I want to show you one more thing. Oh, yes, yes.
I just don't get how you get like 0.2, the probabilities. I just don't get it.
Okay, that's a great question. I want you to talk to your groups really quick. How did I figure out 0.2 for the probability of success and 0.8 for the probability of failure? Everyone's talking with their groups one more time, and then I'll answer that question one more time. Ready? Go. On a 5-choice, multiple choice test, how many choices do you get per problem? 5. How many of those choices are correct? Only 1. So what's the probability of you picking 1 out of the 5 correct? 20%. 1/5, right? So that's the probability of success is 20%. You see, 0.2. What's the probability of you failing and not picking that one? 4 out of 5, which is 80%. That's what we have here. You see? How many attempts are you going to take at this? You're going to guess on 4 problems, right? So based on this data, you will have a very high likelihood of failing the test. So if you're getting Fs on the test, it's because you're guessing, right? You just calculated a 97% chance of a probability of failing.
And so the numbers will always be 1, 4, 6, 4, 1.
For a 4-question test, yeah. Or a 4-trial example.
So
Sometimes.
let's say like it's like a 10-question test, you have to go all the way down to 10.
Yeah, you go 1, 10, you find Pascal's at 10, you're going to work out all 10. right? Or the problem might say, what's the probability of you only getting 9 or getting 9 correct out of 10 on a 10-question test that's 5 multiple choice? So it's a lot of organizing, but you could go to that specific one, which would be the second one. Okay? Good question. All right, let's do another one. Okay, so another way that we use this is in lottery tickets. Raise your hand if you've played lottery tickets, or not played, but let's say your parents have bought a lottery ticket or got one. They're like, you want to scratch a lottery ticket? Anyone scratch their parents' lottery ticket? Okay, I know I did that growing up. I was like, ooh, this is fun. You scratch every little corner, right? Who's been there? Yeah? You're like, take every little bit off. Yeah? Yeah? Okay. That's my favorite. Okay. So, lottery tickets, same example. You know, the California lottery system, they have a percentage of probability. They're like, we're going to have this many winners, okay? The percentage of success. They'll set up their own P. So they're like, 10% of our players will win. That sounds pretty good, right? But how many people lose if 10%? 90, right? So that kind of sucks, which means you have a really high probability. Okay? I don't know what the percentage is. I don't even think it's 10. I think it's even lower than that. Okay? So another example is like a business. They might have a promotion. Okay? So here's an example, number 3. As part of a promotion, a store is giving away scratch-off cards. Okay? So let's just say you go to like Tilly's or something. Okay? Tilly's is like, here's some scratch-off cards. If you scratch it off, you might be a winner. And you can get a free bracelet or necklace or like stickers for Tilly's. And you're like, cool, I like that. I'll try. And they're free, so you're like, what's there to lose, right? So prizes are awarded on 40% of the game cards. So what Tilly's has done is they created 40% of a big stack of cards, and they know 40% of them are going to be winners, which means how many percent of them are losers? 60. Awesome, okay? And you just took 3. 1, 2, 3. If you scratch 3 cards, what are all of your probabilities, okay? Meaning, what's the probability of you getting 3 wins? What's the probability of you getting 2 wins? What's the probability of you getting only 1 winning card? And what's the probability of you not winning at all? Okay? Here we go. This one we're working on together, so let's start writing in your notes. What's our P? What's the probability of success here, everyone? What's that? 40%. So we're going to start with that. P is equal to 40. How do we write that as a decimal? Good, okay. What is our probability of failure here? Good, 0.6. Excellent. Okay, how many attempts are we taking? So our N is 3. Good. All right. Okay, so we're going to go to Pascal's, the 3rd level. What are the coefficients for Pascal's on the 3rd level? 1, 3, 3, 1. Okay. Now we're going to put our P in. P to the 3rd power. So I know that P is going to be 0.4, so I'm just going to jump in and put 0.4 to the 3rd, 0.4 to the 2nd, 0.4 to the 1st, and 0.4 to the 0. Okay? And now we have to talk about failures. I'll use green for failures. Get it? Okay. No one got that. Okay. Okay. 0.6. That one was out to you, Brianna. 0.6. No, no one's here as a failure. I'm using green for a failure.
What is that? Did you run a video next? Oh.
You're not a failure. You are very successful. You'll always be successful. No one here's a failure. Okay. Make that note in the video. No one's a failure. Like it if you're not a failure. I bet no one even watches these. Okay. 0.6, okay? We're going to go 0.6 to the 0, 0.6 to the 1, 0.6 to the 2. I'm going to get in trouble. 0.6 to the 3. That's okay, though. It's all in good fun. Everyone at Benito, you're good. Don't worry. I love you. Okay? Okay, so now we've set up the problem, okay? Let's pull out our calculators. Ready, Robert? Yeah. Okay. Okay, so first one. So now we're calculating the first one, which is the probability of 3 successful cards, meaning we have 3 cards that are wins, okay? So we're going to do 1 times 0.4 times 0.4 times 0.4. and times 1 again, right? What is the decimal answer, everyone?
0.064.
0.064. And what is the percentage there?
6.4%.
Good. That means you have a 6.4% probability of getting all 3 cards as winners. Does that make sense? Okay, next one. What is the probability of getting 2 cards as a win? We got 3 times 0.4 squared times 0.6 to the first power, which is? Okay, 0.288, which is 28.8%, right? So it's a pretty good chance. It's a little bit more than 1 1/4 getting a win, or getting 2 wins. Okay, what about you getting only 1 winning card out of the 3? What's the percentage? We're all doing this. Everyone needs to participate when I'm asking you to calculate, okay?
43.2%. 0.7.
What's that? Okay, we got 0.432, which is 43.2%. Good. And then the last one, what's the probability of me not getting any wins in this game? Yep. 0.216 or 21.6%. Okay? So, if you were to take 3 cards, would you have a pretty good chance of at least getting 1 win? At least 1 win? I think you would, right? Look, what's 40? At least 1 win means you could have won 1 game, 1 card, or 2 cards, or 3 cards. What's the percentage of all these together? It's like 70, what? 78.4, right? You'll see that? So I would play. You would at least win something, right? Okay. And you can apply this for a lot of things. Let's say you're playing a lottery card, or let's say you're at the carnival and they're like, okay, you want to play this game? You figure out what are the chances of winning, and you can do a little math calculation to figure out if it's even worth playing. So, okay. Anyways, we'll talk about this more tomorrow. That concludes the lesson. Sorry it's long, but we'll talk about it more tomorrow.